Hello, this is Brian McHenry of McHenry Software, and it's going to be a demonstration of our msmac3d automatic iteration, automatic optimization, which can take you from a very bad simulation like you're seeing right here to a good simulation, which we'll show right now. How it's accomplished is you have to put in first, obviously, your vehicle specs, your approximations for vehicle drag, and then you also put in your impacts positions, approximate, and your approximate rest positions, and the damage. How we go about doing that is first, down here on the bottom here is targets, point of impact, point of rest. What we're running here is what is called MEA32, which is from a crash tests that were performed by McInnes, uh, documented in SAE paper 2001-0849, and the one we're looking at is this one right here, MEA32. We've done this for about 20 runs, and we're getting ready to publish a paper soon. But what we did is intentionally set the speed very low, and that's why you notice here at 10 miles an hour doesn't seem to work very well. You go in and you put in your impact positions. You notice we have them here. We had a diagram from there, a scale diagram, and we've just matched the impact and rest positions. And then we also approximated the damage. There was no measurements of damage, but from the photographs we put in that the one was all frontal damage, and the other one the side damage, which was pretty well centered. Now, once you get those inputs in, you put the vehicles in, the weights, etc., then we run iteration, which can be run from here or from the grid form of our mEdit3D, but we run iteration. And it gives you a choice to run the best of show from your prior or just the starting, which is at 10 miles an hour. So we say, let's run that starting. And you see that you get a minimum weighted error of about 5,000 and minimum unweighted error of about 8,000. And this again, up here, you see starting is 10 miles an hour and the initial positions of X, Y. We also have a number of bells and whistles in here, which we'll probably trim down, but it's showing you the extent that we've researched to try to come up with a good optimization scheme. What we have here in the pre-iter test is that we do a crash type analysis with some enhancements that Ray and myself have added in the last year or so. We also have additional tests before we get to the optimization to try to give you a good starting position. We want to get somewhere in the ballpark. So let's go ahead and run this. We say run without pause. And this first technique we have, what we call speed calc, and you see that it took from that 10 and 10 mile an hour and came up with a 21 and 6. Now when we exit the iteration, there's this additional pre-iteration testing results where we have a number of tests that we're running that we will include in our documentation. And you see that we come up with ultimately a 26 and 12 for the speeds. Now we say go ahead and iterate, and you'll see that it runs, and it's not a bad match to start, but it still has an error of about 146, and so we're going to try and get that down to lower. The general iteration runs about 50 runs per iteration step, or loop we call it, and so it's about 200 to 250 runs. Takes about 3 minutes, but we're going to probably skip through this or speed it up so you don't have to watch it all. And it's also looking like a pretty good match to start, and so that's demonstrating that our new crash modification gives a good approximation of the speeds. We'll do a few others in future days to demonstrate how this works on other reconstructions. Now at this point, we see that we have a minimum error of about 59 within only 2 loops. So we actually could go ahead and say, let's hit exit, and it'll take the best of show and pass it through. And you notice it's got 59. So now we go ahead and exit. And again, what we had shown you earlier, here is the match. Now if we go ahead and let's go back to the beginning to demonstrate that we have a speed of 12.6 and 27.2. The actual speeds were 27.5 and 11.63, so it's obviously a very good match. And of course, this is in 3D. Not that this has much 3D to it, but just to demonstrate, there's probably a little bit of pitching and rolling. And probably to demonstrate our automatic pan, let's go ahead and get in close. And we'll set that for, we add one. Then we'll move it along here, keep it in the middle, add there. And we'll go to add the rest positions. Now just to look at how that works. And that concludes our demonstration of the msmac3d automatic iteration optimization scheme, which can bring you from, in this case, a 10 mile an hour initial estimate to the correct results. Thank you very much.